So section 1.4 is talking about the different forms of a linear equation. And these are all important that you understand the different forms. So be sure you have these written down in your notes as far as what the forms are, because this will be on your first test where you need to determine, be able to do them into the different forms. All right. So let's start with slope-intercept form. And the reason why we have different forms is because we do different mathematics with different types of forms. So that's why we need to know more than one different way. Okay, so slope-intercept form is y equals mx plus b. That's something you should be somewhat familiar with, the slope-intercept form. So remember, m is your slope, b is your y-intercept. So what you have to know in order to write the equation of a line, so if I'm going to write the equation of a line, in slope, I'm just going to use SI for slope intercepts, you know what I'm talking about, slope intercept form. You have to, first of all, know the, you have to know the slope, and you have to know the y-intercept, which is B. Okay, those are the two things you have to be able to have before you can write it as an equation of a line. So let's look at A. So what I have in A is I have an ordered pair and I have a slope. So what I don't have, I have this, but I don't have the y-intercept. So I have to find the y-intercept. So this is really nice. All I need to do is substitute this into the equation. So I start with our slope-intercept form. All right, so remember this ordered pair. Here's your x and here's your y. So I put this in for y. The slope is given to me, -1. X is 2. So all I have to do is just fill in the information I'm already given and then solve that for B. So 4 is equal to -1 times 2. All right, so I'm going to add 2 here. So B is equal to 6. So once I know this and once I know this, I can just fill in the information. So y equals, the slope is a -1x plus 6. That's the equation of the line. Okay, and that's what we're looking for. All right, so let's try it over here. So with B, I have two ordered pairs. So I don't have a slope and I don't have a y-intercept. So let's start with finding the slope. I do have two ordered pairs and I can use the slope formula. Change in y over change in x. So let's subtract our y's. Either way, so I subtracted this way. Remember, y's go on top. That's the biggest error I see is students sometimes put the x, change in x on top. Y goes on top. And then subtract your x's. Now remember, I subtracted this, subtracted this. You can also take this minus this over this minus this. As long as you subtract the same direction, it doesn't matter which way you go. All right, so here we have 4 minus 2. Okay, opposite of a negative, this becomes a positive. So we have a -5 plus 3. So -5 plus 3 is a -2. So if I simplify that, 2 divided by -2 is a -1. So we have our slope. So m equals a -1. All right, now we have to find our y-intercept. So in order to find the y-intercept, just like over here, I have to know an ordered pair and the slope. So I have two ordered pairs and I can choose either one. It doesn't matter. So we're going to go back to this form. Okay, so let's choose an ordered pair. Let's either one. I'm just going to choose -5, 4. All right, so we'll use -5, 4. And then we know that m equals -1. So let's substitute in. So y is right here, remember x and y. So y is 4. The slope is a -1. The x value is a -5 plus b. -1 times a -5 is a +5. Solve for b. So your y-intercept is a -1. So I'm going to take this and put it into the equation. So y equals mx plus b, which is a -1. So there's your solution right there. Okay, I'm gonna try using a pen, see if it's a little bit better. I'm not sure. It shows up too great. So that's finding the equation of a line in slope-intercept form. You have to know a slope and a y-intercept before you can put it into the equation. So you have to take whatever information you're given and figure out either find b or find m and find b. And had I used -3, 2, I would have came up with the same answer as a -1. All right, so let's talk about point slope form. So all right, so we got point slope form. So the only thing with this pen is I may make some errors and I can't erase them. So bear with me. I think you can see it a lot better. So for point slope form, that is y minus y1 equals m times x minus x1. That's what point slope form is. And you need to know that, all right? You need to be able to recognize what that is. So when I'm given something like an ordered pair, let's say I have these two ordered pairs. And the question is, put this into point slope form. And so when I put this into point slope form, the things I need to know, so this x1 and y1, that's always your first ordered pair that's written down. That's your first ordered pair. And then I have to find the slope, and I don't know the slope, but I can find it if I have two ordered pairs. So I'm just going to label this x1, y1, because that's what you really need to know. So let's go ahead, we have the x1, y1, let's go ahead and find the slope. So to find the slope, we're going to subtract the y's, either direction, change in y, and we're going to subtract the x's, the change in x, in either direction. Just keep it the same way. 7 minus 3, 1 minus 3. So this becomes 4 over a -2. And if I simplify that, that's a -2. So we know m equals a -2. And we're going to use the first ordered pair. That's important. You have to use the first ordered pair. Okay. And again, I want you to remember this is x1, y1. So you know what to substitute it in for. So now I'm not going to know these, and that's okay. They're just like I don't know the y and the x in this one either, right? Because we're just putting it into an equation. We're not solving it or anything. So I leave the y, and then in place of y1, I'm going to put whatever my ordered pair, the 7. Write down the slope. Okay. And then inside here, x, that's the one I don't know, minus x1, and here's the x1 from your ordered pair. And that's point slope form. That's the most difficult one you'll have for point slope form. You got to find the slope, and you take the first ordered pair and you just substitute in. Now let's try something like this. So let's say I was given a table. Let's see here. All right, so I have this table. All right, and I want you to do the same thing, point slope form, given this table. So point slope form, so we have to know slope and we have to know an ordered pair. All right, so we're going to take the slope. We got to find what the slope is. So I want you to recognize that these are ordered pairs. So this would be 2, 3, this would be 3, 5, and so forth. All right, so here's a couple different ways to solve this. You could take any two ordered pairs and find the slope, okay? Just like we did on the first problem right here. But sometimes it's kind of nice on a table if this works out. So if I look from here to here, what is the difference in these two y values from 3 to 5? Well, it's a +2. What's the difference from 5 to 7? It's a +2. Same thing from 7 to 9. All right. And so what about over here? What's the difference in the x values? From 2 to here, it's a +1. From here to here, it's a +1. These all should be the same. +1. If in order for that to be linear, those will all be the same. All right, and that's what we're working with, so it should always be that way right now. So this is the change in y. No matter where I change it, it's always 2. And this is the change in x. No matter where I change it, it's 1. So your slope is the change in y over the change in x. So I could very easily just look at this and say the slope is the change in y over the change in x, which is 2. So I know that m equals 2. Now, if you didn't really understand that, you don't want to do that, just pick any two ordered pairs and use the slope formula. So you would take 5 minus 3 is 2 over 3 minus 2 is 1. So you're going to get the same answer. Just a different way to look at it if you have a table. All right, so now let's pick the first ordered pair. So the first ordered pair that we have is 2, 3. So that, remember, it needs to be the first ordered pair. And then we have our slope of m equals 2. So let's put that into our equation. So y, you see that? There we go. Y minus y1. So here's your y1. Here's x1. So y minus 3 equals your slope. Try to squish that in there. Your slope, which is 2, and then x minus x1, which is 2. And that's point slope form. Okay, so two different examples there on how to do point slope form. All right, so let's talk about standard form. So standard form is ax plus by equals c. So all standard form is, try and get this down, there you go. All standard form is getting your x and y's on the same side. And then your constant, which is just your number, that doesn't have a variable, that's what this c is, on the other side. And that's all it is. So let's say I was given, and let's just go with one that I had here. Well, maybe I'll just make one up here. Let's go with y equals 2x minus 5. And I want to put that in standard form. Well, all I have to do is get the x. I'm going to make this a negative 2x. All I have to do is get everything on the same, the x and the y on the same side. So I know I need the x over here with the y. So I'm going to add 2x here. So we have 2x plus y equals a negative 5. And that's standard form. And that's all it is. Okay, now let's look at another one. Let's say we have y equals 3x minus 1. All right, so let's get the x and the y on the same side. So I'll subtract 3x. So negative 3x plus y equals a negative 1. Okay, that's not quite finished yet. And the reason why is because always your leading coefficient here that begins your equation, so your x value, we always want those to be positive. We don't want to have a negative leading coefficient. And so we'll really be aware of that throughout this course, that we need to change that. So all I have to do, though, is either multiply or divide through by negative 1. Doesn't matter. Multiplying, dividing, you'll get the same answer here. So I'm just going to say, let's multiply here through by negative 1. All right, so that gives us a positive 3x minus y equals a positive 1. It just pretty much changes the signs on everything in there. And this would be your standard form right here. And that's all it is. Getting x and y on the same side, being sure your leading term is positive. All right. So let's talk about using perpendicular and parallel lines. Okay, this is something else I see students struggle with on. And I think if you understand the concept of what you're doing and what it's really not difficult. I mean, I'm not saying it's a simple thing. I don't mean that, but if you just understand that you're trying to find lines that are parallel. So let's talk about parallel lines. So if I have parallel lines, that means that they have exactly the same slope, right? Because I want my lines to be exactly parallel. So their slope is exactly the same. So that means they have the same slope. If I want perpendicular lines, okay, that means they're going to form a 90-degree angle, right? Perpendicular. Okay, this means that their slopes are opposite reciprocals. So opposite, meaning the sign is opposite. Reciprocal, meaning you flip it. So if my slope is 2/3, then my perpendicular slope is going to be the opposite sign, so it's going to be negative, and I'm going to flip the fraction. Let's say I had m equals 2. Well, what would that perpendicular slope be? Well, I'm going to change, let's make it a -2. So I'm going to make it a +2, right? It's going to be positive, and then I want to flip this. Well, how do I flip it if it's a whole number? Well, keep in mind, this is the same thing as a -2/1. So all I do is flip it to 1/2. And it was negative, so it was opposite, so it became positive. So that's really the trickiest part in this, is just being sure you recognize parallel and perpendicular, the difference, and that's what it is. So let's take okay, so let's find the equation of a line in slope-intercept form. Let's see, equation in slope-intercept form. That goes through 3, -2, the line goes through that point, and it's parallel to this linear function here. All right, so kind of just draw a line here so I don't. We want to find the equation of a line in slope-intercept form, so that's y equals mx plus b. That goes through this point and is parallel to this. All right, so let me just emphasize that you only need this to find the slope, and then you do nothing else with it. It seems to really be confusing. Students try and bring in all these numbers to put into my new equation. The only thing I want from this is the slope, and then I'm done with it. So in order to find the slope, though, we have to solve it for y. So your first step here is to, I'll put it up here. Let's go ahead and solve for y. So let's do that. So for 1, we're going to solve for y. So we have 2x minus y equals 5. So we subtract 2x. So negative y. Always put your x value first and your constant last. Keep it in order, slope-intercept form. Just like we talked about above, how do I get rid of this? I just multiply or divide by -1. Either or, doesn't matter. So y equals positive 2x minus 5. Okay, so what is the slope of this? Well, the slope is 2. Okay, so we solve this for y, which is what we did, and then we find the slope. So the slope is 2. Okay. Now, if I want my line to be parallel, what slope am I going to use? I want it to be the same slope because I want my line to be parallel to this one. So if it's parallel, I'm going to use m equals 2. If this were perpendicular, I would take the reciprocal and the opposite sign. So I would use -1/2. So it depends on what the question is, parallel or perpendicular. So I find the slope. Okay, so the slope I'm going to use is m equals 2. So now I'm going to come back over here, and this is what we just did before. So step 3, you want to find the equation of the line. So I have m equals 2, and I have an ordered pair. And now I'm done with this. Don't use anything more here. Students use this -5 to bring over here. Don't do it. Don't do it. You're done. Just get the slope and then forget about it. Cross it out if you have to. All right, so to do y equals mx plus b, we need to have an m and we need to have a y-intercept, which is b, and I don't have the y-intercept. So we have to find b. So we're going to use y equals mx plus b. Okay, so x is, I'm sorry, y is a -2, m is 2, and x is 3. And let's find what b is. 2 times 3. Okay, let's go ahead and solve for b. And so b equals a -8. So now I have a slope and I have a b, and I can put it into y equals mx plus b, my slope-intercept form. So y equals 2x minus 8. So if I were to graph this line and this line, they're going to be parallel. And this line goes through this point because I use this point down here. And so you can see here when I solve this for y, look at their slopes are the same. So I know they're going to be parallel. So it's not a super difficult concept. You do this all the time. but you just have to recognize that I only use this for the slope and then I'm done with that equation. So let's try another one here. Let's let's do, we'll call this A. Okay, so let's say we have a line that goes through -2, 0, and is perpendicular this time, perpendicular to 8x minus 3y equals 7. Now, if you want to try and do that, just pause and go ahead and try and do it yourself if you want to, and then you can come back on and check to see how you did. So the first thing we have to do, right, is solve for y. Oop, way up here, we've got to solve for y. So let's do that. We're going to solve this for y. So 8x, get y by itself. Always write your x value first. Keep it in intercept form. And then we'll divide. Now we're going to have a fraction. That's okay. Don't let it scare you off. Negative divided by negative is a positive. Positive divided by negative is a negative. So just kind of work on those signs. Look. I have a lot of room here. There we go. All right. So we solved it for y. So what is the slope? So the slope is 8/3. So what we're wanting is the new line we're going to create needs to be perpendicular to this one. So that's why we have to solve for y, so I can find the slope. So if I want to do perpendicular, the slope I'm going to use in my new line is going to be opposite sign, which is going to be negative, and the reciprocal of that. So I just flip the fraction. And that's what I need to bring over for my new line. So over here now, I'm going to use m equals -3/8 and the ordered pair they gave me. And I'm going to now create a line with that. And I'm done with this. Just get rid of it. Done. Okay, cross it out again, like I said, if you need to. So let's put this into a y equals mx plus b. So y is 0. Our m is -3/8. Our x is -2. And we don't know what b is. So y equals mx plus b. So like I said, I would go ahead and let's go ahead and multiply this first part through. So -3 times a -2. This is like a 2/1 if you want to do that. That helps you. Just multiply straight across. So that's going to be 6/8 plus b. All right, so because we're not going to have, this is a 0, we can just subtract 6/8. If this were a number here, if this were a 5, I'd go ahead and multiply everything through by 8, get that out of the denominator. But because it's 0, we don't really need to do that. So we'll just subtract 6/8. And we have our b. So we have a slope and we have our b. So let's put it into slope-intercept form, and that's our equation. So y equals our slope times x plus whatever our b is. And here's your answer. And this line is going to be perpendicular to the original line that I was given here. And if we look at when we solve for y here, notice our opposite reciprocals. You could just look at those and see that those are going to be perpendicular. All right. So I have one more problem I want to do with you, and this is a modeling problem. And we will be using our calculators quite a bit, but I'm not going to have you use the calculator on this one. I want you to do this analytically. So analytically means we're going to do this by hand. That's what analytically means. All right, so I'm going to draw out, let's start with a table here. I have to add to that, I'm not sure, we'll see. All right, so here is the x value. I'm going to put them up here, and this is the y. This stands for years, and this is for cost. Okay, so here is 2018. We'll just do the first, maybe first 4. And then here's the cost. All right, so let's start with this. So here's what the question says. So these are projections for Medicare spending. All right, Medicare spending. in billions of dollars. In billions of dollars. So that's what this table means. So what a hint that they give you on this is, and this works anytime when you're dealing with years and you start dealing with, like you put this in a calculator and you're trying to find a good window, you have to go to the 2000s and it's just a lot and your numbers are really big. So what they suggest on this that you don't see, but this is what I always suggest when you're doing an X value and we're talking about years, take your first one and always just make it 0. So we know that 2018 equals 0. So then 1 year later is going to be 1, 2019, 2020, 2021, and so forth. So instead of using this, I'm going to use 0 instead for the X value, just to make it easier. So I'm not dealing with big numbers. And you can always do that when you're dealing with years. All right. So the question is find a linear function to model this data. So we want to find a linear function. Okay, linear function. So that's a straight line. So remember to find, that's like slope-intercept form. So slope-intercept form. So we need to find the slope and we need to find a y-intercept. So let's think about the slope. Now we can do it in 2 different ways. We could take this ordered pair, which is 0, 574, this ordered pair, 1, 642, or any of these ordered pairs, and use the slope formula, change in y over change in x. Okay, we can do that. Another way that I kind of showed you on the last table is I could just say, well, what is the difference between these two? Well, it's a positive 68. I didn't leave myself a lot of room there. Well, what's the difference from here to here? Well, it's also 68. And from here to here is 68. Well, what's the difference here? It's 1 on all of those, right? So I don't really have to use the slope-intercept formula if I don't want to. I'm sorry, I don't have to use the slope formula there. I can just say, well, my change in y's are 68. So 68, and my change in the x is 1. Now, if you have no idea what I'm saying, if you don't get that, just put this into y minus y over x minus x. Okay, use those 2 ordered pairs and do that. You get the same answer. You'll get 68. Now I have to find a y-intercept. Well, what's really nice with this, and I'm going to tell you this in just a second. Let's just take this first ordered pair and use it. All right, so we can find b. Because those are the 2 things we need. We need a slope and we need b. All right, so let's find b. So let's take our first ordered pair. So 0, 574. And we know our slope is 68. And let's put it into slope-intercept form. Okay, exactly what we've been doing. So y is 574. The slope is 68. The x value is 0 plus b. So this just becomes 0. So now we have our y-intercept. Now just as a hint, if I have this right here, I see that's written, that's my y-intercept. When x is 0, that's my y-intercept. So if you always do your years beginning with 0, then this is always going to be your y-intercept. So I wouldn't have to do this step. I automatically know that it's going to be 574 where it goes through the y-axis because that's where x is 0. So I wouldn't have to do this. But if you forgot, didn't recognize it, just take an ordered pair and put it in for x and y. You could use any ordered pair that you want, but you don't want to get big numbers. I'd go with the small numbers if you can. All right. So now we have a slope and we found this to be 574. So our linear function now, because it's a function, I'm going to use an, what are we talking about, Medicare? It doesn't matter. Let's just use f of x. Let's just put it into a function, write it as a function form, okay? And so mx plus b, there's our linear function. Okay. So it's not too difficult to do. It's the same process of what we've been doing in a real world modeling problem. Okay, so now the next part I'm going to ask, so this is part A. Part B says find, use f of x to estimate, or I'm not going to say estimate, I'm going to say to find Medicare costs in 2024. So this is how we do a lot of data, is we do predicting. And you've seen probably through the COVID and such that sometimes their data is not always correct, right? They had some trouble with it was very exponential and we didn't always match what has happened. And that happens. You know, we're just making a prediction. It isn't always going to turn out the same. And there's lots of variables that come into play. But this is saying, all right, so now that I have this function, can I find what the Medicare cost would be in 2024? Well, sure. I mean, I could do this by hand, really, just by counting down, but maybe I wanted to say 2080, and I don't want to go down 80, you know, or find 80 by trial and error. So let's just figure out 2024. Okay, what number would this be over here in 2024? Well, 22 would be number 4, right? So 22 would be 4, 23 would be 5, your 2024 would be 6. So I could also figure 18 to 24 is 6. 24 minus 18 is 6. You know, you could do it that way. So that's how I know I want to use 24. So I'm going to use 6 in my equation right here. So f of x is equal to 68 times 6 plus 574. So if you work this out, 68 times 6 plus 574, that's going to equal 900, I believe, $982 billion. So we took data, we made a linear function out of it, and we predicted what it was going to be in the future, what it was going to cost in the future. You can do really kind of neat things with math, and I think you guys will be able to do that. So I probably should write in here, what was the B? 574. So that's all I have for you right now. So good luck with your homework on it, and we will talk to you soon. All right. Have a good one.